Hey, Algebra 2. So here in 3.4, we're going to continue factoring. This is going to come up again, but now we're looking at different ways to factor polynomials. Here we go. In your book, they have the definition of the factor theorem here, and essentially this is just reminding us of that the factors are going to give us the zeros of a function. So for example, the zeros here would be x to be -5 and x to be -1, because if we plug those into each factor, it would make them 0. So here we're going to be figuring out, is this binomial actually a factor of the polynomial? So in this first one, remember the 0 here would be -1, and we're trying to figure out, is that a 0 of this? So you could plug in -1 for x in each of those and see if the equation equals 0. But we just learned about synthetic division, which can make our job easier. And so when we do that, we see that my remainder is not 0. And since the remainder is not 0, this up here is not going to be a factor. Okay, setting up the second one, my a value is -2 because that would make this factor equal to 0, and we're testing to see, does -2 make this equal 0? So I set up my synthetic division. I put in a 0 here because there is no x squared term. When I do my synthetic division, I do get 0 as a remainder. And so that means that, yes, x plus 2 is a factor. All right, on this one we want to know, is this a factor of this? But synthetic division only works when the x has a coefficient of 1. We can make that happen by dividing everything by 3, and that means absolutely everything in the polynomial. So now we can set up our synthetic division. Looking at this first factor, our x is going to be 2. So go ahead and set that up, do the synthetic division, see what you get. So I end up with 0 as a remainder, so yes, this is a factor of that large polynomial. Now we're going to do some other methods of factoring. The first one we're going to do is factor by grouping. I'm looking at this polynomial and I'm seeing that there are common factors in each half of the polynomial. So in this first half, a common factor is x squared. So if I factor that out, I would have 2x plus 1. And then in the second half, I see that 4 is a common factor. And when I factor that out, I end up with 2x plus 1. So that's really handy because now these two factors are the same. So by essentially undoing the distributive property here, I could group together the x squared plus 4 and then the 2x plus 1. Now notice if we did the distributive property, we would be taking x squared times this and this, which is happening right here, and I would take 4 times this and this, which is happening right here. So we're just kind of undoing all of that. And we end up with that as our factors. This can't be factored anymore, and so this is our answer. Here's another example. When you're factoring by grouping, you want to be looking for common terms in your pieces of your polynomial. So again, if I go here and here, and here and here, my first one, I could factor out an x squared, and so I'd be left with x minus 1. Over here it gets a little bit tricky just because we are subtracting in here, so I'm going to factor out a 25, and then I have to be really careful to make sure I get back to what I need. In that first factor, I have an x, and then in this next factor, to get back to positive 25, I'm going to need to have a -1 there. And I'm just going to double check it. -25 times x is -25x. -25 times positive 1 is going to be that positive 25. So now I can take the x squared minus 25 and put those two terms together. Those came from right here and right here. And then I can be multiplying that by x minus 1. And again, just go back and look. If I do the distributive property, right, I would take x squared times this and this, which would be all of it. And I would take my -25 times this and this. And so that's exactly what's happening here. We're just undoing that distributive property. Now I'm going to keep looking to see if I can factor more, and I think I can factor this x squared minus 25 a little bit more. I could do x plus 5 and x minus 5. That's kind of going back to the idea of completing the square, that type of factoring. and I still have x minus 1 there. And so this one has 3 factors, and those would be it. Okay, here's how this one ends up. In this first part, I factored out an x squared because x squared times x is x to the third. X squared times negative 2 is negative 2x squared. Over here, I factored out a negative 9 because negative 9 times x is negative 9x, and negative 9 times negative 2 is a positive 18. So I grouped together the negative, or x squared minus 9 into a term right here, and then that's going to be multiplied by the other term, x minus 2. I can factor this a little bit more into x plus 3 and x minus 3, and so I end up with 3 terms in my answer here. Another way to factor is looking for sums and differences of cubes. This is going to be a helpful reference for you to look back at in your book, so make note of that. Factoring this one down here, first thing I'm going to do is factor out the common factors. So 4x is common in both of them. I would be left with x cubed in my first term when I do that, and I'd be left with 27 in my next term. Just remember, if I do the distributive property, I would end up back to where I started. Now this portion right here is the sum of 2 cubes. It's 2 cubes being added together. So I'm going to rewrite it like this, which means that I'm going to rewrite it as x cubed plus 3 cubed. 3 cubed is 3 times 3 times 3. That does get us 27. Because now I can see what my a and my b are. My a is going to be x, and my b is going to be 3. So when I factor this out, this is going to be x plus 3, that's the a plus b part, times a squared, so that would be x squared, minus a times b, so that's 3x, plus b squared, so that's going to be 3 squared, or 9. And so I could rewrite this as 4x, I still have that, but this is a sum of cubes, which we just did right here. And so my final answer is all of this. This next one is a difference of 2 cubes. I could rewrite it with my a and my b, so I have to think what number times itself 3 times gets me 125, and that's going to be 3. And so that'd be 5d cubed. That's going to be the same thing as 125d cubed. Minus 8 can be written as 2 cubed. And so here's my difference of cubes. This 5d is going to be like my a over here, and 2 is going to be the b. And so when I factor this, first thing I have is a minus b, so it's going to be 5d minus 2. Then I have a squared, so it would be 5d, I'm going to put that in parentheses and square it, plus a times b, so 5d times 2, and then b squared, so it'd be plus 2 squared, which would be 4. And I'm going to simplify, because there is some simplifying we can do. 5d squared would be 5d times 5d, which would be 25d squared. 5d times 2 is 10d plus 4. So there it is, factored as a difference of cubes. The last thing we want to do here is make the connection between what we see on a graph and the factors of a polynomial. So we graphed this function right here, and we can see the zeros labeled right there. And so we know there's a 0 at x equals 1, at x equals 3, and at x equals 4. So we're going to use that to factor this polynomial. So this means that one factor has to be x minus 1, because if x is 1, that would make that factor 0. Then the next factor could be x minus 3, because if x is 3, that factor would be 0. And then the last one would be x minus 4. So there you go. That is that polynomial factored out. So if we multiplied this out, we would get back to that polynomial we started with. All right, great job working through that factoring. Keep getting practice with it. Try out those practice problems. Ask questions as you need. Keep it up, guys.